Ta-da, 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 ta-da. So we're going to discuss about how we are going to get this blood flow from the tumor. This is T2, this is stir, hypo on T2, hyper on stir. It is showing restriction of diffusion on B800 and ADC images as you can read. But this is arterial spin labeling post-process image. This is the ROI from which we have drawn, and this is what we have gotten, 324 ml per 100 gram per minute. Now you're wondering how do we get there, and it's kind of simple. For that you will need few things. You will need this software called MRI Cron. You will need this software called DCM2NII, and you will need this image from your Siemens or GA thing. And we are using 3 Tesla Siemens, so this is it. So I just copied the path here, and I'm going to just minimize it, and I'm going to tell you how do I do that. So dicom to neft, and you just type it here, the path, and it completed it in 437 milliseconds. It's awesome. Just be careful that you have selected this. Sometimes something else is been pre-selected and you won't able to get through even the first stage. So once you are done with it, you can just check whether it's been done, and look at that, it's done. So it's done now, and what you want to see here is which series it is. So what I like to do most of the time is get this ASL file into another folder, and that's because ASL file will have 91 or so parameters. So I will just rename it ASL for demo. Normally I rename it with a patient number or something after anonymizing the data. Of course, all of this data is anonymized, so don't worry about that. So why we are doing this is because you will see why not, why I'm doing this. So just copy this. Okay, so as I told you, two important softwares, this and this. Now you can close this, but the most important software here is this, Matlab. And actually more important than Matlab, and after Matlab you need to have another thing too, which is which is ASL toolbox. I think I got it here. I think this has to go off in editing. So yeah, this is the toolbox. So you go there and you download this toolbox from this site, which is this is the manual of toolbox. And speaking of ASL, this is Angelo Mosso, and he's the guy who actually first thought of measuring, the blood flow, and this was his instrument, Mosso's instrument. As the person will start thinking, this table will tilt towards that. Aren't you lucky that you got to see it? Okay, so I was not planning to show you. Anyway, so this is ASL toolbox, and this is very cool guy, Ze Wang, and this is his email. He is very nice and he replies to your email, and that's how I got into this ASL thing. Whenever I have problem, I emailed him, and then there is a group, ASL toolbox 2 group. So what you need to do is you need to go there online and download this thing. What's happening? I just ASL toolbox. Oh yeah, I think this is it. So you need to go there and download this toolbox from here. So anyway, after you download it, you install it in Matlab by adding it to set path. It's quite easy. After that, you need to give command. Now if you are a if you were a IT person in your past life like me, this is like very simple for you. But if you are actually a hardcore medical resident, then you need to learn about something like coding or something, but not really. You just need to know what how do you write commands and how do you do it. Mostly it is just copy pasting. For example, you cannot actually for example, if this is the command and if you miss as, then this won't get executed and you will identify something, and then it is quite okay that will tell you that, do you actually mean this, and you're like yes. Now you click on it, and another window will supposed to pop up right here. Now you just copy paste your all right, it has forgotten it. So you just copy paste this little guy on that. It's quite easy. Just copy. Sorry, these are like little things which before you do it. Yeah, got it. So something is really wrong. This is not the file. This has only 3 files. Either I have, okay, this is really wrong. I need to stop it. Okay, pause it. Actually, I was going to pause it and tell you but this is important. This is troubleshooting step. So for example, if you do not have those 91 files and you say done, it will pop up again and won't go on to the another site. Like for example, this has come up, but this is not going to solve the problem there because all the images are not there. So this is an error. So you need to learn how you overcome it. So for example, here is our data itself. So just bear with me. I will just go back and get full data. So now what I have done is I have copy pasted this to series here, which we had taken later when we realized that we haven't have gotten a whole data. So this is very important. Sometimes the sequence might just stop and you might end up with not having complete set of images, which is very bad. So this is useless. So I need to delete this too. Yes. So we need to repeat this step again now with the same software of this. It's not really difficult now because now you know how do I do it. So this is just I'm doing it again. Maybe this is better so that it reinforces this takes 3 times more because those are 91 images. So yeah, and then we are going to make the same folder again. um, you can name the folder anything like ASL XYZ. Just don't think the name of folder is important. What you need to understand is you cannot confuse M0 image, which is a control image, with the labeled image, which is ASL, which is 001. That you cannot confuse this two. So I just I need to check whether this 14. Yes, it was 14. And to avoid confusion, then I delete another one. So yes, so let's just copy it here and let's just run the command again. Once you have ran the command, you can just search it with the A or something. It's quite easier, and then voila, now you have 91. Oh, now this is very important, and you should not have something like this um, selected or something. So you do Control A and then you put all of them together, and that's very amazing if you do that. And then you said done. Now this is another step. So every time it will keep on asking some things. For example, simple subtraction. For example, label minus control. So these are the important steps. This is how ASL is calculated. Arterial spin labeling is done. If you are interested, actually, I could actually show you a little bit of my presentation. So ASL actually is a video. I'm not going to have sound here. Sorry. Okay, cool. So what actually ASL is you have this labeling pulse. which is perpendicular to this carotid, and then you sample a control from here, and after this time interval, which is shown in purple, this thing will be sampled, a labeled image, and then you have two set of images, which is a labeled image and a control image. So then you will just minus the label minus control, which was this. Easy, isn't it? Now, do you want to create images? Yes. Do you want to calculate, quantify the cerebral blood flow? Now, you need to understand is that time cerebral blood flow is the only thing which people used to calculate ASL for. Mine is one of the novel research where we are measuring it in arterial for breast cancer too. So, do you need output in bold? No, not really. So, actually, ESL could be used for as a bold thing too. So, what you know what's bold? It's used in fMRI. So yes, it can be used there, but it's another maybe another day we will discuss it more in detail. So you just keep on going. Okay, this is for pseudo continuous ASL or just a ASL. So mostly nowadays machines have pseudo continuous ASL, but you should actually go and talk with your people. Now this is also important. 3 Tesla, yes. So ours was Siemens 3 Tesla images. Then labeling time per second. So labeling time here was actually 1.8. So you need to be sure about that, and then post label delay that and TE and then M0 image. Now M0 image is the one if you remember, we have left it behind. So let's go here. So now you won't see anything. So you go up, then this is very important step. This is a very small step, but it's so important that you delete that image slash thing, and then you click on this, and then you said done. Once you do that, they said, do you want to draw a CSF ROI? You say yes. Now you might ask me, there is no CSF in breast. How are we going to calculate it? Uh, I'm sorry, I don't know how to answer to that. But basically what I normally do is I just press anything between 10 and 11. For example, I press 11 and I get another slice, a better slice, and then I just press 0. When you press 0, you can actually select it. And then I see the hyper things, which could be calculated as a wrong blood flow or something, and then I select it. The grayish area, you don't want to select bad or worst area or something. So then it will go and quantify it, and there you are. Your mean CSF, which is coming out here, is actually -8. So there's something has gone wrong or something. Not really. I will tell you, like sometimes these things will go in minus. You don't have to worry about it. So you just cancel it here, and then you open this, and then you open. Okay, now you need to just copy paste your thing here. Yes, and then you press here, and then you just open it, and here you are. You got. Now one more thing you need to remember here is, look at that. That's the thing. That's the tumor here. Yes. So one more thing you need to remember here, which is very important, is that it will be shown in the opposite thing. So for example, for radiology people, this is very difficult to understand that this is left and this is right. This is so technological, right? So I'm just going to make it bigger, and normally I'm using actually Windows Surface pen here for that. So I just select it, and then I draw it very fine ROI, if you see what I'm doing. So once I'm comfortable with it, I just keep on drawing it, and then I will draw it on another thing too. If you're seeing it carefully, you know that I'm actually not going beyond. I'm trying to stay as close as possible. After you do that, you just select draw and save UI. Actually, our ROI is a little bigger, so CSF might come smaller or something. So just label it UI. It will save as a nifty image, and and for documentation, and you know that you in future you will require this for presentation and all. So you just save this and just save something. Just save it. Yeah. Once you do that, you just you can just cancel it, but normally I like to keep it. Then this is another command, which is get mean ROI. Now this is not actually available in ASL thing. I will actually try to put a link to it. This good guy, what's his name? Zen, what's his name? Yeah, Ze Wang. He actually mailed it to me when I asked him how does he calculate it. So yeah. So first you need to pick the VOI image. Yes, I done. And then you need to pick the source image, and this is the source image here. Done. And there, the answer. Now this is showing actually 700 ml per minute. That's because we actually uh, maybe overshooted it or something. But yeah, you got the basic idea. This uh, man, that this tumor is very aggressive. Actually, this was Barrett's 5, and yes, you got it. Awesome. Now, what you can do is you can just again open something, uh, the same thing, and you can actually play around and try to get to another ROI. For example, I'm just going up, and there you go. This this thing. So you can actually try to find what's the blood flow in here. These were the lymph nodes, if you remember. So just I'm just going to save them, and what was it? Save UI, just possibly lymph nodes. So just save them, and again you need to document it. So whatever you do, you need to document it, because you see the spatial resolution here is very poor. So and especially when you are a radiology person, you have this left and right trouble too. And I can understand this as an Excel image, and one of them is sad and one of them is alive. But it's very hard to make out all this. Now I'm used to it, so I know what's what. But I would suggest that take a bloody snapshot. It's quite easier when you have this, when you save this images, so that you could actually know what you're really doing. So this is the lymph node ROI. You say done, and then you just be careful that not to minus it from perfusion or something. Just cerebral blood flow mask. And look at that. That's exponential. Oh my god. I never have gotten this result. My god, that thing is very vascular. And this is the case we haven't actually have done it. So yeah, this was one of the new cases which we have gotten recently. My god, that's quite if you know, that's a lot of blood flow if it's going. Uh, what I want to tell you is that method is very amazing and looks nice, that you get all these values and get all these masks, and you can actually see them, and you draw with your, you know, you can actually get a pretty good idea about what's actually you're doing. But these things are new, and meaning what I'm trying to say new is that uh, you need to understand that it will take some time to standardize all these things, because not many people are using it. So for example, if I'm using it, I don't know if I'm doing it right or wrong, whether my results are being matched, uh, like are others getting the same results, is the software detecting only the machine thing. You really don't know. So there is no standardization yet. But this open software, this is open source, right? So this, now what I've done is I have taken combined ROI. So just let's see whether we get it the same results. So what I'm trying to tell you is, um, using this free software is important, because if you have a Siemens machine, right, and I have a GE machine, then we cannot really talk using the proprietary softwares, because they will give different values, and you're not really sure that which which one is saying nice and which one is not, and there is no crosstalk between machines that time. But using this this openwares, oh my god, yes, this actually calculated the average of this. Awesome. So actually using all these openwares and amazing things, we could actually, get a good idea and talk with each other, you know. So so this was about how to do ASL. You won't believe it, but this actually took me almost a year to, to get around and get to do this, And it's amazing that now I can teach you all that. That time I used to think um, that there should be a YouTube channel for this, and people who are doing it, like for example, Ze Wang or something could have put it, and maybe they're very very busy and something. So, what I'm trying to tell you is that time I actually did search whether there is anyone who has done it and would show me step by step. Every little step matters. For example, set path. If you see, I have set path. There's ASL toolbox. There's SPM. All these things are very very important. The small things. Other small thing was this software. Another small thing was this software, and another small thing was this, which was not even in that batch file, which he emailed me. So yes, you have to be very persistent about it and go on. So this will be my talk in Vienna. You're welcome to attend it. I think it will be on 3rd of March in Sky High Stage. That's what they're calling it. So cheers and see ya.